Distinguished faculty members, I would like to share a story about failure. This story did not unfold in an examination hall or on a competitive field, but within the very first business analysis model I built with my own hands, a model that ultimately became my most important moment of intellectual awakening in understanding complex systems. It begins in the domain I knew the best, algorithm development. As part of my FTC robotics team, my primary responsibility was to develop an autonomous targeting system. While the robots moved rapidly under manual control, my algorithm had to integrate radar-style distance detection and angular calculations in real time, achieving precise targeting amid chaotic battlefield conditions. I was deeply fascinated by this process of seeking optimal solutions within deterministic rules, writing logic in Java and validating each iteration through match performance. At the time, I believed this represented the standard paradigm of problem-solving: clear inputs, controllable variables, and quantifiable objectives. That belief was challenged when I attempted to apply the same mindset of a fundamentally different system, a merger and acquisition case involving a coffee chain with over 300 stores. And initially, like a Navi engineer, I reduced the problem to an optimization equation. Given operational data, I searched directly for a magic parameter that would maximize profit. I quickly identified a group of star stores with average profit margins as high as 77.4%. I treated them as ideal templates and hastily concluded that the solution lay in having underperforming stores replicate their cost structures and labor efficiency. Reality pushed it back hard. When I applied this optimal template to struggling stores, the result was not improvement, but confusion and resistance. One community store manager told me bluntly, "You want us to schedule like the flagship downtown store, but our mornings are for parents dropping off children, and our afternoons are for students doing homework. Your efficiency feels inhumane to us." That moment jolted me out of the deterministic fog of algorithm. I realized that a commercial network of 300 stores was far more complex than a robotic battlefield. Each store functioned as a node embedded within a unique social ecosystem. What the single required was not a single scalpel, but a diagnostic framework. I stopped the brute force replication approach and instead constructed a three-tiered diagnostic model, drawing on the structured layered thinking I had developed through algorithm debugging. The first layer was financial, examining profit structures and cost components to identify sources of financial leakage. The second layer focused on operational efficiency, analyzing foot traffic patterns, labor hours, and outputs to uncover process bottlenecks. The third and the most crucial layer addressed brand consistency. I designed quantitative metrics to analyze social media sentiment trends, monitor variance in core product standards, and assess the uniform.